These massive data centers are the beating heart of the AI boom that's reshaping our world, and they're hungry for more electricity. That's one of the reasons that for the first time in a decade, demand for energy in America is spiking. To keep up, we're burning more and more fossil fuel, and fast. But there's another path, a clean, safe, virtually limitless source of power, fusion energy.
Fusion is the way the sun works. Only here on Earth, we've actually struggled to be able to do it in a commercializable, cost-effective way. We've built now a number of machines showing that we can do that.
So what would it take for fusion to power the future? Let's find out. For nearly a century, scientists have chased the promise of nuclear fusion. In the 1930s, physicists realized that fusing light atoms could release immense energy. The first experimental reactors came a few decades later in the 1950s. So how have we not still conquered fusion almost 100 years later? To understand why, you first have to understand the science. Nuclear fusion is the process of smashing together two light atomic nuclei.
You actually can take those two atoms, the core of those, the nuclei of those atoms, and push them together, overcome their internal atomic forces. And what happens when you do that? They actually fuse and form a heavier element.
Unlike nuclear fission, which splits heavy atoms, fusion joins small ones and can yield far more energy per gram of fuel.
That new element has a tremendous amount of energy. That helium is born with on the order of 10,000 times the energy that it started with.
That energy comes from the tiny difference in mass between the reactants and the products, converted to kinetic energy. It's only about 0.1% of the fuel's mass being converted into pure energy, but that's millions of times more efficient than fossil fuels.